Okay, so for this problem, we have the field f of xy equals xy squared and y, and x. We're wanting to calculate f dx, where c is the boundary of the region enclosed by y equals x squared plus x, and y equals x cubed minus x. And it needs to be below this equation and above this equation. That's going to be important. It also tells us that it is positively oriented, so that may be important as well. So we're going to first see what region we're trying to find. X squared plus x is this parabola type shape. Goes through the origin. X cubed minus x actually comes down, up through the origin, down and back up, and they meet up here. This is at 2. You can see that by setting these equal to each other. So if we have x squared plus x equals x cubed minus x, we can set this equation equal to 0. So we have x cubed minus x squared minus 2x equals 0. If we pull an x out, we get x squared minus x minus 2 equals 0. Well, obviously we have an x equals 0. That's the origin here. And then we can break this apart and get that x minus 2 times x plus 1. Well, that gives us 0 to negative 1. Now, I didn't draw this very proportionately, but this is actually at negative 1. This is 0 and this is 2. That will also be important later. Now we want to see if they're conservative or not, because that's going to tell us how we're going to solve it, what we can do to solve it. So first, let's remember that this is P and that's Q. Now we want to take the derivative of P with respect to Y and the derivative of Q with respect to X. So if we do P here with respect to Y, the Y becomes 1, so it's X squared. With respect to X, that becomes 1. Now these aren't equal, so we can see that they're not conservative. So that makes us think, well, maybe we can use Green's theorem. But there's 2 parts to Green's theorem, mainly, that we really need to figure out. Now, if we go back, like I said, this is important because that needs to be below this equation, above this one. Well, we can see that that means this is the region we're trying to find. If it was opposite, this would be the region we're trying to find, but we're trying to find this. So with Green's theorem, it needs to be positively oriented. Well, they gave us that, so that's satisfied. It also needs to be closed. Well, we can see that that's closed there. So that's good. So now we can use Green's theorem. Now to do that, we have the double integral of the derivative of Q with respect to X minus the derivative of P with respect to Y. So with that, we get 1 minus X squared dA. Now we want to find our bounds. Well, I'd say we want to do this vertically, because if we do it horizontally, I mean, we have 2 different equations here, and that's just going to make it a big mess. So if we go dy first, let's plug this in. Let's go dy dx. Well, dy, from the bottom, we have x squared, or we have x cubed minus x, because it's above. and then we go all the way up to x squared plus x. Now, in terms of x's, obviously it starts at 0, and we go all the way over to 2. That's what we found over here earlier. So let's solve now. In terms of y first, well, we don't have any y's, so we just get 1 minus x squared times y from x cubed minus x to x squared plus x dx. Now if we plug those in, we're going to get 1 minus x squared times x squared plus x minus 1 minus x squared times x cubed minus x dx. Well, I'd say we should simplify this first, factor them first, because, or multiply them out, because it's just going to make it so much easier. So if we do that, we get x squared plus x minus x to the 4th minus x cubed. And over here, we have a negative out front. We get x cubed minus x to the 5th plus x cubed dx. If we multiply that negative through, well, this is 2x, positive 2x cubed. So we'll get negative 2x cubed, positive x to the 5th. It looks like we can do a little more there. Let's start, we have x to the 5th minus x to the 4th. And then we have negative 1x cubed minus 2x cubed. So we get negative 3x cubed plus x squared. And then we have x and an x, so plus 2x dx. Now we're going to take integral of that. So we get 1/6 x to the 6th minus 1/5 x to the 5th minus 3/4 x to the 4th plus 1/3 x cubed plus x squared, all from 0 to 2. Multiply that out. I'm going to make it quicker. We get 2 to the 6th. 2 to the 6th is 64 minus 1/5. 2 to the 5th is 32 minus 3/4. 2 to the 4th, 16 plus 1/3. 2 cubed is 8. And 2 squared is 4. Now, let's see. Let's just multiply this out. We can simplify this and get 32 over 3 if we divide by 2. Minus 32 over 5. That 4 goes away. Minus 12. Plus 8/3 plus 4. We see we have 5 and 3 in our denominators. So we can get a common denominator of 15. If we multiply by 5, we get 160 over 15 minus times 3, which is 96 over 15. We get negative 12 times 15 is negative 180 over 15. 8/3 times 5. 3 times 5. We're at 40 over 15. And then 4 times 15 is 60. Now, if we multiply that out, or if we simplify that, add and subtract those numbers, we get let's see, 160 minus 96 minus 180 plus 40 plus 60, and we get negative 16 all over 15. So that is our final answer for that problem. It's a long one, obviously, but there it is.